A very good morning to one and all. Today, I'm going to discuss with you about USB sensors, embedded sensors, distance measurement with ultrasound sensors. These are the three topics which has been picked up from your third module from Principles of Internet of Things. And in this module, we have discussed multiple kinds of hardwares and multiple kinds of sensors from our previous classes. And today, I'm going to let you know about these four sensors, which are USB sensors, embedded sensors, distance measurement using ultrasound sensors. These are the three topics which are left over from your concern third module, which is controlling hardware and sensors. As you guys know, why we are using these sensors in our IoT system. And the main purpose of using sensors was to extract the data, to grab some information from the concerned things which are inherited in a IoT system. Let's have a quick view. Let's enter into our major concern subject, which is Principles of Internet of Things. In this today, I'm going to discuss about a particular module called Controlling Hardwares and Sensors. In this, till now, we have discussed the above concerned topics, such as, once again, I will have a quick view by reading out the things. The first one is controlling hardware we have seen, and connecting LED we have seen, and connecting buzzer and switching high power devices with transistors, and controlling AC power and devices with relay, and controlling servo motor and speed control of DC motor, unipolar and bipolar stepper motor sensors, and light sensor, temperature sensor with thermistor, and voltage sensor, and ADC and DAC, which is analog to digital and digital to analog connector. And coming to temperature and humidity sensor, which I discussed in my previous class, along with voltage sensor and ADC and DAC. And this is having DHT11, and there are some other extensions also for this particular kind of sensor, which is DHT22 and HP230T. Like this, different kinds of sensors are there, which is a little bit extension, where in this DHT11 sensor, we are using temperature and humidity with a specific range. To increase that particular range, we have to go for DHT22, and above that also there are some sensors which, along with the temperature and humidity, you are also having pressure in it. And for that purposes, in our particular IoT system environment, in an IoT system, we need to use as per the requirement of the concerned user. Right? Got it, guys? And today, we have discussed about motion detection center, wireless Bluetooth sensor, as well as level sensor in my previous class. And now I'm going to tell you about what exactly USB sensor was and how embedded sensors are going to be used in a IoT system, and how distance measurement is going to be calculated with the help of ultrasound sensor. These are the three topics which I am going to discuss today. Those are USB sensor, the first one, and the second one is embedded sensor, and the third one is distance measurement using ultrasound sensor. These are the topics which I am going to discuss in today's session. Let's have a quick view. What are the objectives and what are the outcomes which are related to these particular things? USB sensors in IoT. What exactly IoT stands for? IoT stands for Internet of Things. And now we are going to discuss about USB sensors in this Internet of Things. The main objective of using these USB sensors are for gathering the data from the environment for monitoring or for controlling purpose. The main examples, which include temperature sensors in greenhouses as well as pressure sensors in water systems, along with the light sensors in our smart lighting system. You guys have seen this smart lighting system in your smart homes, as well as you guys have seen your pressure sensors in our water systems in our smart home. And also you guys have seen temperature sensor in your smart home, which is on terrace greenhouses are established, right? In those areas we have seen these temperature sensors. Along that, these are the objectives of utilizing these USB sensors in IoT system. And now what exactly the outcome of using this particular USB system? We are going to provide the real-time data which is has been taken the live feed from the IoT system, which is going to given for analysis and automation purposes. Why analysis has to be done on the generated data, which is a real-time data. For suppose, take a real-time example. Currently, I am delivering a lecture to you. The entire thing was going to be recorded by the camera which is placed in front of me. And the data which has been grabbed, this is going to be the data which is sent for analysis. In that analysis, they are going to remove the ecosystem. They are going to remove the noise. They are going to add some beautiful graphics behind me, or else they are going to cut the unwanted data which is not necessary in the streaming. Like this, there are n number of things which can be utilized with the help of our IoT systems, right guys? And by taking that real-time data which is going to be used for analysis and automation purpose, here we are going to use that data for optimizing the processes and for improving the efficiency and also for gaining the valuable insights into the environmental conditions. This is what USB sensors are used in our IoT. What embedded sensors are in IoT? Till now we have seen USB sensors. Now what exactly these embedded sensors are in IoT? The main objective of these embedded sensors in Internet of Things was, after collecting the data on a particular device performance, we need to verify how the function of that particular device was, internal working structure, and how the surrounding environment has been of that particular device, and how the data can be utilized for different kind purposes such as condition monitoring, predictive maintenance, user experience optimization. For those purposes, this has to be utilized. And what was the outcome of using these embedded sensors? Here, after using these embedded sensors, we are enabling the remote monitoring system and also for controlling of devices and for improving the device reliability and lifespan. And here, I'm going to personalize the user experiences based on the sensor data. This was the main objective and the outcome of utilizing these embedded sensors in IoT system. And coming to the next factor, which is ultrasonic sensors in IoT for measuring the distance. The main objective of using these ultrasonic sensors was to detect the object which are in distance. We are also measuring the distance and we are also navigating the surroundings. This is very, very helpful in security applications. Along with the robots, we are designing robots. We are seeing smart robots nowadays, and we have seen in hotels also robots are serving. How those are identifying that so and so table has been came and it should be turned off. With the help of this ultrasonic sensor only, the distance is going to be calculated and the data is sent to the robot, and the robot is delivering the things to our particular table, guys. And that much advancement was there in our IoT. And also in autonomous vehicles. Autonomous vehicle means smart driver. I can switch on the auto mode and I can sit relaxedly in a car or in a plane or whatever the concern automobile thing was. Automatically it is going to take care with the help of these sensors. It is going to function automatically. And also if there is any kind of obstacles which came suddenly, automatically it is going to, with the help of these sensors, it is going to predict it and it is going to push towards the brake. This is how the thing ultrasonic sensor was utilized in a IoT system. And what exactly the outcome? Here the outcome was to improve the safety standards and also to make the system more automated in various kinds of applications. With the help of these ultrasonic sensors, which are going to be used for performing n number of tasks such as object recognition, path planning, collision avoidance. Like this, we can do n number of things in ultrasonic sensors which are used in IoT. And I can say overall, by based on these particular objectives and outcomes, with the help of these sensors in different kinds of IoT projects, we can design a beautiful applications which improve the IoT system. And also with the help of these sensors and collecting the data, with that data after performing the analysis, which will be more helpful for the physical world, which is utilizing our resources which are related to IoT industry, which helps us to improve, to make better, to feel better, right? By using this decision making things to improve safety, to improve efficiency, all these things can be done with the help of these three sensors. Now I'll go in detail how this ultrasonic sensor will function, how this particular sensors are going to be useful for us. First, I will start with discussing about USB sensor, what this USB sensor was and what this ultrasonic sensor was. We'll see in the next slides. Now we'll start discussing about USB sensor. What these USB sensors are. USB sensors are the most common type of sensor which is used in any kind of IoT application due to the inherited thing which is a wired connection. Why? Because USB need to be connected to a specific device. Then automatically there will be certain scenarios. There will be a breakdown of USB sensors where the applications in IoT are going to prefer some other things. And how to understand these USB sensors? It can be connected directly to a specific host computer or to a microcontroller board which we are using, which is USB. USB. I am calling multiple times. What USB was? USB stands for Universal Serial Bus Interface. What USB was? Universal Serial Bus Interface. USB stands for Universal Serial Bus Interface. And by using this interface, we need to provide a digital output signal to host the device which can be read and which can be interrupted. By using this particular USB sensors, there are different kinds of things. There are multiple types of USBs which are going to be measured the range of environmental parameters which we are going to utilize in our IoT system. The parameters such as temperature, humidity, pressure, light, gas, whatever the parameter was. For everything, we are utilizing these sensors. What are the different kinds of areas, different kinds of applications which are presented, which are using our USB sensors in IoT systems? The first one is rapid prototyping and development. What the first application was? Rapid prototyping and development. During the development phase, in any kind of IoT project, we can utilize these USB sensors to offer a quick and convenient way to connect to these sensors which are established in the computer for testing and data acquisition purposes. And coming to the second application, which is data logging and monitoring. By using USB sensors, it is very simple to log in the applications when we collect it to the environmental data, when it is going to compute the analysis. That is how data logging and monitoring can be taken care. And coming to the third one, which is educational use cases. For educational purposes, there are n number of learnings about these sensors and IoT applications. Here, by utilizing the USB sensors, we are using user-friendly way to interface with the sensors and to visualize the sensor data with our computers. These are the different kinds of applications where USB sensor is utilized in IoT sector. And what are the limitations which are existed for this USB sensors? What limitations? Why limitations are required, sir? Why? Because USB requires only a wired connection, only limited mobility, and having power consumption in it. Coming to the first factor, first limitation, wired connection. USB, Universal Serial Bus Transfer Interface, which is a wired in nature structure because the sensor limits the place flexibility, which is compared to the wireless networks such as Bluetooth, Wi-Fi. By using those things also we can transmit the data without wires. And coming to limit mobility, Here we are using some applications which require sensors to be placed in remote or hard to reach the locations, and USB sensors become more impractical due to the cable length constraints and also power consumption. While some USB sensors are low power devices, but it still requires a wired connection to the powered USB port, where we are having a limited battery power IoT devices. And now we will see the alternatives for these USB sensors. Alternatives for USB sensors are wireless sensors, microcontroller shields, and these are the two alternatives for USB sensors which are utilized in IoT system. We can replace these USB sensors with the help of wireless sensors and with the help of microcontroller shields. How wireless sensor will work? As I told you, Bluetooth, Wi-Fi, cellular communication, all these are wireless sensor networks. With the help of these things, it is more flexible and we have more scalability compared to the USB device. And here the battery power and it can be placed in various locations without needing any direct physical connection between the sensor and the computer system. And along with the wireless sensors, we can also use an alternative which is called microcontroller seed. Here, microcontroller seed. Some microcontrollers have dedicatedly having some kind of shields which are add-on boards, which are inherited, which are using multiple kinds of sensors for eliminating the need of separate USB sensors and simplified connections. These are the two different things, wireless sensors and microcontroller shields. This can be used as an alternative for USB sensors in our IoT system. When to consider these USB sensors? Sir, you said about USB sensors and the functioning structure and the alternatives. Why? When it has to be considered, when this sensor has to be considered, when we are designing for rapid prototyping and testing during the development phases, we can use these USB devices. And also educational purposes or learning about sensors, basic logins, and also applications where a computer is always nearby to provide data. And I can conclude you this particular USB sensor session, which have a nice role in our IoT development and IoT use cases, which are designed with the help of wireless sensors and having more advantages. I can confidently say that while implementing an IoT system which gives you a good flexibility, a good scalability, and provides a various suitability for battery powered devices, that I can say you with USB sensors. Now I will go for embedded sensors which are going to be utilized in IoT. What embedded sensors are? In a single word, I can say you it was a backbone for data collection in Internet of Things world. What embedded sensors are? It was a backbone in the sector of Internet of Things for collecting the data. And in general way, I can say you, without eyes, can we see anything? No, right? Here, the main sensor is eye. By using this sensor only, I am recognizing that who is watching me or else who is coming in front of me. If I am not having these eyes, am I capable of extracting the information? No, right? If someone passing in front of me also, I don't know. If I don't have these eyes and if I don't have these ears, we can say this embedded sensors as eyes and ears. Why? Because even nose also, by smell also we can detect, right? If we don't have these three, if I don't have eyes, if I don't have ears, if I don't have smell, then can't we do anything? No, right? In the same similar way, embedded sensor also like that. Here, how deep dive we are going to work the significance in the IoT system. What are embedded sensors? Here, embedded sensors are like traditional sensors which might connect to a computer by using USB. Embedded sensors are manufactured and integrated directly into the IoT devices. And what are the different kinds of varieties? There are n number of varieties which are designed to detect the more specific physical phenomena, which is the common types, which includes temperature sensors, which are thermistors and thermocouplers. Thermistors, temperature sensor. That was the best example. Pressure sensor, piezoelectric and capitative. This was also a sensor which can be used. Humidity sensor, which is resistive and capacitive. And light sensor, which are having photodiodes and photoresistors. Motion sensor, which are having electrometers and gyroscopes. Gas sensor, which are having electrochemical and metal oxide semiconductor. And there are n number of sensors which are going to convert the physical quantities for measuring the things such as temperature, light, pressure, etc. into the electrical signals. This is how the things are going to be utilized and why these embedded systems are important in IoT. I can confidently say that I already told you, to gather the real-time data in any kind of environment, we require a sensor. Here, embedded sensors will play a major role in Internet of Things to grab the information, which is real world information. The data which can be utilized for various purposes, which includes monitoring and control, and also predictive maintenance, and also environmental monitoring, and also usage interaction. These are the 4 different kinds of purposes which embedded systems data can be utilized for IoT system. First, by monitoring and controlling, by using smart thermostats which are going to be used for temperature sensors to regulate the room temperature, while wearable user motion sensors are going to be used for tracking the activity levels. Coming to the predictive maintenance, industrial equipment requires embedded vibration sensors which are going to predict their potential failures before they occur. And coming to environmental monitoring, in environment day to day we are having fresh air, right? Air quality becomes a crucial role. So we need to place these sensors to track the pollution level in air, to know the soil moisturizer, to know multiple things by in a IoT system. And coming to user interaction, motion sensors in smartphones, which allows you a guest control, where light sensors are going to be used for adjust the brightness of the screen on based on the ambient light. And what are the benefits which we are going to get? The benefits are miniature, low power consumption, easy to use, variety of options. These are the 4 benefits which we are going to get with the help of these embedded sensors. And what miniature was? Here the small size which makes you very flexible for integration, the compact of IoT devices. The first one is miniature. And second one, low power consumption. Due to its miniature, the sensor is going to utilize only less power compared to the other devices, and it is very easy to use, which have an interface between the connection between microcontroller with IoT devices. And there are variety of options which are there in embedded sensors for doing diverse sensing needs which are utilized in our IoT applications. How we are going to integrate these microcontrollers? Embedded sensors are going to connect with these microcontrollers. The brain of the IoT devices are microcontrollers only, which can read the electrical signals from sensors, which is where we are going to convert the signals into a meaningful data with the calibration factors and calibration. And also there are n number of calculations which are going to be known to you. And also we are going to process the data for taking good decisions based on the sensor readings. And also we are going to communicate the data and cloud with other devices for future analysis and control purposes. This is how we are going to integrate the embedded sensor in microcontroller. And now we will see how to choose a right embedded sensor in an IoT system. Here we need to select the most suitable sensor, depends on your project requirement. First, what exactly you are measuring? Either you are measuring temperature, or you are measuring pressure, you are measuring light, or something else. It should be known to you. Then only it will be compatible. And the next factor is, what is the required accuracy and what is the range you needed for your project, and also power consuming limitations and environmental factors such as which is suitable for temperature, humidity, potentiality, pressure, all these things can come into control. Like this, by based on these 4 factors, we need to identify the things. What are the different kinds of examples which are related to embedded sensors? The first one is smart thermostats. Here, by using this, temperature and humidity is going to be taken care which is smart control. And coming to the next one, wearable fitness trackers, which are motion sensors, which is also an accelerometer. It is going to track your steps, how much distance you traveled, what was your heart rate, and what was the temperature of your body by using temperature sensors. And also have a look what the third factor was, smart agriculture system. Smart agriculture system is a solid moisturizing sensor where the temperature sensor and light sensors are used to optimize the irrigation and crop health. And coming to smart homes will play a major role. Why? Because motion sensors for security, for occupying detection, temperature sensor for thermostats. If there is any leakage of gas, leak sensors are going to detect, and also water leakage. Anything can be detected easily in smart homes with the help of these embedded sensors. And also in industry also, vibration sensors for predictive maintenance, and pressure sensors for monitoring the industry process, gas sensors for leakage detection. These are the different kinds of examples where embedded sensors are utilized in our IoT system. And also I am providing you a small learning resource which might be helpful to the topic which I discussed till now, which is embedded sensor. And you can find out more about embedded sensors by using these particular links, such as embedded sensors with Arduino or sensor types for IoT projects, which will gives you more idea additionally to the thing which I discussed. And also I told you for every sensor in my previous classes also, in market there are some smart kits which are available, which are attached to microcontroller. To that microcontroller itself there is a the same sensor, either it is embedded sensor or voltage sensor, whatever the sensor it can be, which is going to be utilized to your IoT project. That has to be considered very carefully, and it gives you space for performing experiments on that particular microcontroller before implementing your IoT project. And if you are known about these sensors in detail, your role in IoT industry, you can create n number of intelligent devices which are going to interact with the physical world. And also you are able to gather valuable data and automate tasks for fostering and more connected the efficient world. And the last sensor in this particular controlling hardware and sensors topic module was distance measurement by using ultrasound sensor. Here in the realm of IoT and the real world management of Internet of Things was ultrasonic sensors, which are often cost effective and also a versatile solution for measuring distance. Here there is a complete breakdown how this ultrasonic sensor is going to work, what are the different kinds of applications, how to integrate this ultrasonic sensor with our microcontroller. The first, ultrasonic distance measurement principle based on sound emission. The sensor is going to emit a high frequency sound wave which will be calculated by the ultrasound beyond the range of human hearing towards the targeted object. And next, echo reflection. When a sound wave hits the object, it bounces back, which is an echo. For suppose, hi, how the echo has been transferred. Got it, guys? And how the echo has been reflected towards us, right? It can be received by the sensor. And coming to the next factor, time measurement, where sensors are going to measure the time before it takes for the sound wave to travel towards the object and back. And what are the how we are going to calculate the distance? The distance is going to be calculated with the speed of the sound in the air and also the known value, approximately 343 meters per second at room temperature. By dividing the round trip time taken of sound wave travel from one point to another point and coming back also, this can be twice per sound. We can calculate the distance of the object also. Factors which are affecting the accuracy was temperature, object material, sensor angle. The first one is temperature. Here, speed of sound with temperature. Calibration might be very specific when we are calculating the precision applications. And object material. There are some objects which absorbs the sound. Highly observant materials like thick curtains might dampen the sound wave and affect the accuracy also. And coming to sensor angle, the sensor which is placed, which is perpendicular to the target object. So for calculating the accurate measurement, these are the factors which can affect the measurement. and factors affecting accuracy, temperature, object material, sensor angle, which we discussed so far till now, and also the applications which are utilized these ultrasonic sensors are obstacle detection, smart inventory management, liquid level measurement, smart parking system, and security systems. These are the different kinds of applications where ultrasonic sensors are utilized. Now I will discuss with you in detail about this obstacle discussion. Robots and drones which can use ultrasonic sensors for navigation purpose and to avoid obstacles purpose also. And coming to smart inventory management, to track the product levels in the shelves or in bins or inventory control. And liquid level measurement. Liquid level measurement can be used to fill the levels of liquid which are placed in tanks or container. Smart parking system, which is going to detect the presence and absence of the vehicles in the respective parking spaces. And coming to security systems, which are going to trigger alarms when a movement has been detected unknownly in a specific range. This is how the things are, and how we are going to integrate this microcontroller. Actually, this microcontroller is going to be integrated with the ultrasonic sensors with a simple digital and analog output. Digital sensors and analog sensors. Digital sensors are things where outputs a high signal when the sound is emitted and the low signal when the echo is received. When we are shouting, automatically the wave is going to produce a high sound. When it is coming back, a low signal echo is coming back. This is how the microcontroller is going to measure the digital reduction, high signal duration to determine the round trip time. And coming to analog sensors, which are going to produce a output of voltage signal proportionally to a round trip. The microcontroller converts the voltage during the analog to digital converter before calculating the distance. How much popular our microcontroller platforms are? Arduino, which offers libraries, which offers a number of tutorials specifically for designing the ultrasonic sensor integration. And also Raspberry Pi. In this Raspberry Pi, there are different models which are presented in Raspberry Pi. And in this, it can be used for programming by using Python to interact with the ultrasonic sensors. These are the things which are presented. Additional to the topic, additional to the things which I discussed in ultrasonic sensors, I am providing some learning resources which might be helpful for your career for building a good IoT project, which are ultrasonic sensor with Arduino, ultrasonic sensors by using Raspberry. These two topics will give you the best thing. And what are the different kinds of sensor connection methods in hardware as well as code examples for distance, project ideas while using ultrasonic sensor. And there are starter kits, as I told you, which are going to provide you for giving a hands-on experience for before designing the project. And I can confidently say, by learning about this ultrasonic sensor, being as a IoT developer, in by using the microcontroller and the IoT device, we are going to calculate the distance measurement, and also we can create wonders and we can interact with the outside environment. Being as a good IoT developer, you can do an automation tools very wonderful. That I can promise you. This is about the things which has been discussed so far from the past 5 to 6, 7 classes. I have discussed about controlling hardware and controlling sensors, which might be very helpful to you while designing a particular IoT project based on this. Right, guys, we will see with some more modules in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.